Okay, let's start with the syllabus. So on this particular section, so this part of the chapter, you need to understand what a moment is. You need the definition. You need the definition of a lever and the definition of a couple. Activities, you should engage with simple experiments with a number of weights. We'll do that when we get back to school. And you should also be doing appropriate calculations related to moments, levers, and couples. The Science, Technology and Society section, so the application of these principles, makes up about 10% of the Leaving Cert course. Torque on taps and doors, handlebars on bicycles, and reference to moving coil meters, so galvanometers, ammeters, voltmeters, and simple motors. We'll do these in time, but I'm focusing on these two to start with. And then the next thing, the conditions for equilibrium. So equilibrium just means something is balanced. And in this case, if it's balanced, we say that one, this complicated sentence here tells us that the forces up and the forces down are equal, the forces left and the forces right are equal, and the forces in and the forces out are equal. So there's no net force acting on the body, so the body will not accelerate. The second one then is saying that the sum of the moments is 0, so there's no turning effect caused by the force either. So for a body to be in equilibrium, it can't be accelerating and it can't be rotating. That's what that's actually saying there. You should be able to do calculations on it, and we'll have a quick chat about static versus dynamic equilibrium. Okay, to the log table and we'll take a look at what formula are required for this section. And we're looking for moment here. So if you scan down there, there's no moment on page 50. You have momentum, which is a different quantity altogether. Conservation of momentum, different quantity. So they don't apply at all to the moment that we're talking about. Centers of gravity, usually not applicable to Leaving Cert physics. We have moment of inertia, but this is a different moment. This has to do with objects spinning in dynamic equilibrium more than static equilibrium. So the objects are actually spinning. And the moment of inertia is how difficult it is to change the turning effect of an object. So this is more applied maths rather than Leaving Cert. And now we get to these things. Angular momentum, nope, here we go. Moment of a force. So the formula that you need to know here, moment of a force is equal to F by D. I'd like you to be able to get state what F and what D is. We also have this thing called torque of a couple, which is the same formula. I'd like to know what that D is. It's different to the one above. And the rest of the equations are not relevant for this section at all.